We have a PV pressure volume diagram given, and we have some questions about it. So for part A, we are looking at process from A to B, and we want the change in internal energy, and you notice that from A to B there's no change in volume. So since delta V equals 0 for this process, the work is 0 for the process AB, and using the first law of thermodynamics that says delta U, the change in internal energy, sometimes it's written delta E, is Q minus W. That tells us that delta U is going to equal Q for AB. Let's write these subscripts here. And we are told that in the process AB, 150 joules of heat is added. So we know that QAB is 150 joules, which means that the change in internal energy for process AB is 150 joules. For part B, we're asked to find the internal energy change for process ABD. And notice that we can think of process ABD as from A to B, then B to D. And from B to D, we have an expansion under constant pressure. If you look at your diagram, you notice that from B to D, the pressure is constant, the volume is changing. So from B to D, we have constant pressure, which means that the work is that constant pressure times the change in volume, and the pressure is given as 8.0 10 to the 4th Pascal times the change in the two volumes, which is 5.0 10 to the minus 3 meters cubed minus 2.0 times 10 to the minus 3 meters cubed. And if we multiply all of these out, we get 240 joules. So the total work for ABD is going to be the work for AB plus the work for BD, which is going to be 0 joule plus 240 joules, which is the same as 240 joules. And we are told that QBD is 600 joules. So QABD is going to be QAB plus QBD, which is 150 joules plus 600 joules, or 750 joules. And now we can say that the change in internal energy for the process ABD is going to be QABD minus work ABD, which equals 750 joules minus 240 joules, or 510 joules. Excuse me. Part C is asking the total heat added to the process. ACD, and if we look at the process ABC, ABD, and ACD, we notice that the beginning and the ending are the same, and since delta U is independent of path, so we only care about beginning and ending, we know that the internal change of energy for ACD is going to equal the change in internal energy for ABD, which is 510 joules. So now if we look at the work done for ACD, that's going to be the work from A to C plus the work from C to D. The work from A to C is under constant pressure, so that's going to be the pressure times the change in volume. And the work from C to D takes place under constant volume, so that is 0 work. So we know that the pressure at A to C is 3.0 times 10 to the 4th Pascal, and the change in volume again is 5.0 10 to the minus 3 meters cubed minus 2.0 times 10 to the minus 3 meters cubed, plus 0 doesn't matter. We do this, we get about 90 joules, which means that Q from ACD is going to equal the change in internal energy for ACD process minus the work for ACD process, which is 510 joules minus 90 joules. Sorry, it should be plus, which is 600 joule. Right? If delta U equals Q minus W, then Q is delta U plus W. I made the mistake, so it should be 600 joules.